Looks like we're live now. There's 3 minutes, so I'm going to set up a few things before we start. Right, we start. First, I'll take a look at the list of the question, the checklist. I will go through the list and make sure that we'll cover all the topics. And also, if you have any question, please post on the chat, and then as soon as I see the problem, I will do it. It is better for me to do the problem in the chat than to just pick up random prompts. Right. So the first one we have is the product rule or the quotient rule. There will be more of that, but the product rule will be number 4, and then 5 will be the quotient rule, and then we'll go back to the product and the quotient rule later in the lab 3. Right, so first, the product and the quotient rule. So I'll take a look at 3 and 4. 4 and 5. Right, so product rule. So that is the product rule. Right. This one we use the product rule first, and after that we will not use the product rule. Right. So first we'll find the derivative of this. So we'll let u equal to either one of them. I will let 5x minus 5 be u, and then v square root of x plus 2. I can rewrite that as x to the 1/2 plus 2. And then I'll take derivative. 5 derivative of this will be 1/2 x to the negative 1/2. And that's it. Derivative of 2 is a constant. It is a constant. Derivative is 0. Right. And then we use the product rule. So we need to have u, u prime, v, and v prime. Right. So derivative is a product rule. So u prime v minus u v prime. It doesn't matter because lab 3 and 4 the question kind of go over the place. If you have any question, just ask, and then I'll go back and forth between the two labs. Yeah. The reason I start with this problem because in the checklist we start with the product rule and the quotient rule. I think this is what we start. That is the product rule, and then we'll do one in quotient rule. Right. Now we multiply it out. 5x to the 1/2 plus 10. And now when I multiply this out, what we do is we multiply the two things with the same base. So I just put formulas here. We will add exponents. Just keep the minus here for a moment. Right, 5x and x to negative 1/2. By default, we can always set this to the first power. Right, and then 5 times 1/2 is 5/2. And then x to the first, x to negative 1/2. We just have x, and then 1 minus 1/2. I just add the powers, 1 and negative 1/2, so it'll be 1/2. And then negative 5/2 x to the negative 1/2. Right. remove the parentheses and then simplify. And minus 5/2 x to the 1/2, and then minus with the negative, so it's a plus. Right. And we can only do one thing here, x to the 1/2 and x to the 1/2. Those are like terms. I can combine them. So we will have 5 minus 5/2 is wait, there's something. Oh, that's a plus, sorry. Right. Then 5 and 5/2, that's 7 and 7 and 7.5. So 5 and 2.5, so we write 15 and a half. I mean 15 halves, sorry. And minus 5/2 x to the negative 1/2 and plus 10. Right. So that is where we use the product rule. Sorry, that was a plus. Right. We can also use that without the product rule. So we just multiply it out. Okay, thanks. I will try that. Right. We can also multiply it out. I will write this as 1/2 plus 2. So 5x to the 3/2. Again, this to the first power, multiply it out. 3/2 plus 10x minus 5x to the 1/2 minus 10. Right. So for this function, I just multiply it out. And then I take derivative. So that will be 5 times 3 over 2 x to the 1/2 plus 10 minus 5 1/2 x to negative 1/2, and that will be 15 over 2 x to the 1/2 and then minus 5/2 x to negative 1/2 plus 10. So either way, we should get the same thing. So that is the product rule. So that's that formula, straightforward. Or if we can just multiply it out, we don't need to use the product rule. Right. So that was for 5. On lab 3, there will be a bunch of questions in for number 2. This is the product rule and the quotient rule. We'll visit that in a minute. Now let me just finish for first this problem first, and then we go to the chain rule, which is a bunch of questions here on lab 3. Of course, I think I will focus more on lab 3 because lab 3 we don't have the key, and there will be a lot more difficult questions. Anyway, so quotient rule. Let me go with the rule first. So the top kind of like what we have here, except in the product rule is the plus, and in the quotient rule is the minus, and we do have divide by v squared. So on this one there's no other way around, we just have to go straight to it, and we have so u will be the top, v the bottom. So we just again find out u prime, v prime, and then we put in the product I'm sorry, quotient rule. So u prime 3x squared v x minus 1 minus u, and v prime is 1 over v squared x minus 1 squared. Right. So I will multiply it out, 3x squared 3x cubed, sorry, minus 3x squared minus x cubed x minus 1 squared. Right. 2x cubed minus x cubed will be 2x cubed minus 3x squared x minus 1 squared. We can factor out something, but that doesn't help much, so just gonna leave it like that. So that pretty much the product rule and the quotient rule. I just briefly go to number 6. We have the marginal average, meaning first we find the average, and then we find the marginal, meaning the derivative. So what we do is we multiply it out and then divide by x. Try to simplify first, and in this case we do not need to use the product rule or quotient rule, just multiply it out and then divide by x. Try to simplify. I think we did something like this in class, so we're not going to do that. Right. Next we go next item on the list is the function decomposition, but that seems easy, so we go straight to the chain rule. So lab 3. Right. So we have a few questions in the chat. We have 1C, 1D, and E, and then number 4. Right. Right, so 1C. So I cannot zoom in anymore, but that as big as it is. Right, so y equal to 0.2 to the 5x. So this is the chain rule. All of these problems are chain rule. So I put 5x in the box. So you have we have 0.2 e to the box, and the box is equal to 5x. Let's put u in it, and then we take the derivative. Derivative of e to the u is e to the u, and then we have 0.2 in front of it, and after that derivative of 5x is just 5, and we multiply. So the chain rule is derivative, the product of these derivatives 0.2 times 5. Do that first, this number and that number. It's just 1. So end up with being e to the u. And u is 5x. So we just that. So derivative of e to anything is e to whatever that is. Right. Now we have something that is different than e, the base 4. So we have, if we have another base, then we have ln of a and a to the x. Right. So I put this in the box, x squared plus 2, and we have 3. It is not 3.4, it is 3 times 4 to the box, and the box is x squared plus 2. Right. So we have derivative of this. Right. 4 to the u, that is, this formula will be ln of 4 and then 4 to the u. Of course, the 3 in front of it will be just times it. Derivative of x squared plus 2 is 2x. Right, let's try to simplify what we have here. So 3 and 2x will be 6x. Usually if the second term just have one term, then you try to multiply in front. It will look better. So that will be 6x. And then we have ln of 4. And then 4 to the u. And where u is x squared plus 2. Oh, 0.2 times 5, that is 1. Right, so. And yeah, so that is E. Right. E, actually I'm going to do F, the problem. 1F as well. Because all of this derivative kind of related. I'm going to do F from 1F first. This first. Right. So we have ln of x is 1 over x. And on E, we have ln of a different base. We will have 1 ln of the base times x. I forgot the derivative, of course. Right. So, let's have to do this one first. We'll put this one in the box. And we have ln of the box. And the box is 2x plus 5. So derivative is 1 over u that is 2. So the derivative of ln of u is 1 over u of u is just 2. You can multiply on the top. And u is 2x plus 5. Right. Now 1e the same way. If we put this in the box, because when we get used to this, we can just drop this step and we're just going to write this, which is perfectly fine. Right, derivative. Right, now this is log base 5 unlike ln, so we're going to have 1 over ln of the base times u, and then derivative of this 6x minus 7. We can multiply that to the top as well, but yeah, let's just do that. And ln of 5, u is 3x squared minus 7x. Right, so yeah, so that's part of the problem. One, so we have a bunch of chain rule here. Similarly, we have a lot more in the left hole as well, but those are the typical problems that you might expect to see on the test. Potentially, we just have, all the derivatives, exponential rule and logarithmic rule. You should see all of that on the test. At least these two. Those two I guarantee will be there, definitely. Right, so that is 1. Right. Next we will do 2D. Okay. Right. By the way, does anybody have a question on the either 1 or 2 and lab 3? Because we're going to do after 2D, then we go to something else. Right. 2D. There are a few things we can do. We can use properties of the log and simplify things a little bit. If not, it will be a little bit more complicated. So the properties that I will use, there are 3 of them. I'll just write. So meaning we can take the power outside as a coefficient. We should do this to save a lot of time. And we say the 4 power goes out. We have that. And after this, the problem will reduce to pretty much like in 1e. Right. So I'll do this one first. After that, we write all the properties of the log. Right. So decompose this. So u and u. We take derivative for a constant which will be there. Log base 3 of u will be 1 over ln of the base times u times derivative 2x plus 2. That is the derivative. Right. Next, we have a 4 and the 2x plus 2, all of which we can put on the top. And we have, you can multiply it out or just leave it like that. I will just leave it like that. And then x squared plus 2x. Right. So that is why. Take a look at that. I will write the other two properties of the log. Right. And after you do this one, we should take a look at, we will not do it, but just left for number 15 will be, 13 will be very similar. Right. The other two formula for the log, I said we don't need to know it, but it will be nice. We save a lot of time if we do. Right, so those are the formulas for the log, properties of the log. So that is 2D. The rest of the problem 2, either product rule on A and B, and C, the quotient rule. Right. Since I have a question on the chat, I will go there first. Lab 3, number 4. Actually, number 3 is a lot more difficult. Anyway, keep it for a moment. Right. Lab 3, number 4. Suppose that the total revenue, so is that for the marginal revenue, meaning we just take derivative, and after that find and interpret that result. Right. So what I do first is we write this function. It will be a lot easier if we do. So especially just the fraction there. So we have 1,000 there. 1. Here we have 1 over 500. Will be 0.002. Of course, the simple math there. And it will save a lot of time when we do the derivative, when we write like this. 2, 0, and then 2. Of course, I forgot the x. Right. Either we multiply it out, or we just go ahead and take the derivative, because the marginal meaning derivative. Oh, yeah, it is. Of course not. I mean, usually the problem on the test you will not see a long-winded problem like this. All of the question on the test only have one part. You will not have multiple parts on one question. Right. Even though it's not on the review, but at least we get to some of it because you still need to turn it in. Still need to do it. Right. So I decompose that into 1,000, and then the box square. The box 1 minus 0.002 x. Right. So we take derivative. 1,000 u squared will be 2,000 u, and this negative 0.002. I multiply that, and we should have 4. Yeah, negative 4. Negative 4u. Which means negative 4 proper notation. Negative 4u is 1 minus 0.002x. So that is the derivative. So we just write that is the derivative. Or we just multiply it out. Negative 4 plus 0.008x. Right. Now, find and interpret the result of marginal derivative, the marginal revenue at 400. So we just put 400 in for x here. So I use a calculator on this one as well. Right. So what I do, I will store the 400 into x. So put 400 store into x, and then we can do the math here. Negative 4 plus 0.008x. So I have negative 0.08. Right. So we found it will be, sorry, can see with the calculator there. Right. Negative 0.8, which means this is the revenue if we produce an extra item, and that will be approximately equal to the revenue of the 401st item. Yeah, that is the revenue of the 401st TV. If we want to produce one more, we're gonna, the revenue will reduce by this much. Oh, that was the question in 1 and 6. I have a question about the marginal and the average. The marginal is the derivative, and the average is where we divide by x. So if we have marginal average, meaning we divide by x first, that is the average, and then take derivative, which is the marginal. I will not complete the problem one lab 3 number 3, but at least we have to get started. Since I have the question on this problem, so I just go ahead and work it out. So yes, you can use the product rule and then the quotient rule, but I will not use any of them because it will be better just to simplify this. So I multiply it out 40x squared minus 35x minus 24x plus 21 over x. Combine like terms in the middle. We still have derivative on the outside, so whenever we finish everything inside, we will take derivative. So 40x squared minus 59x plus 21 over x. What I do is I will split all three of them out. That gives us 40x minus 59, and then this, instead of write 21 over x, write 21x to the negative 1. And the derivative of that is a lot easier to do. Derivative of 40x is 40, that constant, derivative 0, and that is 21x to the negative 2. Pretty much just that. Yeah, so yeah, so if we can multiply it out, we don't need to do the product rule. If we can divide and simplify like this, we do not need to use the quotient rule. On this problem we cannot, because we cannot split the denominator. We can split the numerator, and that allows us to do this. Right after this problem, well, we stop at problem number 3 on lab 3, and then we go to chapter 5 where we do the critical points and all the derivatives test. Right. Lab 3. It is not part of the test, but because it's complicated, so just go over this as well. So first, suppose the demand. So we have this equation. The Q is the quantity, that's greater than 1, and P is the price. And we want the marginal revenue. Of course, the marginal is derivative. And the revenue is price times quantity. This will be a long problem, so I will better just do half a page and then we'll continue on the other side. Right, the price is that. Sorry, just 100. I don't know why I do that. 100 plus 50 over ln of Q, and the quantity is just Q, and I will multiply it out. 100Q plus 50Q over ln of Q. Right. Derivative of the first one is easy. Derivative of the second one requires to use the quotient rule. So first denote this as a function of q. Right. So quickly on this one, u and v. U is 50, q. V is ln of q. U prime is 50. This is complicated, so probably we will not simplify it. Now derivative of 100q is just 100. That's easy. Now the next part is the quotient rule. So u prime v minus u v prime over ln of q square. Right. Not much to simplify except the q. So pretty much that. Right, so that is the marginal revenue. So the revenue and then the marginal, we take the derivative. Right. Next, use calculus to approximate the revenue of the night. Of course, just like the one we just did, in order to find the revenue, the cost, or the profit of whatever it is always the one with the marginal of 8. We'll estimate the next item. Next, the marginal profit. Of course, I'll let you finish the problem by putting 8 into it. Next, the profit is equal to the revenue minus the cost. Of course, I can just take the revenue minus the cost, but this time I do want the marginal, I do want the derivative. So what we do is we can take the derivative of everything, meaning that the marginal profit is marginal revenue minus the marginal cost. Right. The cost is that. So the marginal cost, the derivative, is just 100. So meaning that we don't have to subtract it first and then take derivative. We just take derivative of all of them and subtract. Meaning that we're going to take this, the marginal revenue, minus the marginal cost. Of course, the 100 cancel out, and we just have this. And the next one, we just need to do that. That could be no problem. So So that cover a lot of derivatives problem. Next, we'll go to the next item on the list. 5 critical points. So critical points. So looking at number 14, 15, and 16. Definitely, we need to look at 16 for sure. Right. Right. Critical points. Critical points is where derivative equal to 0 or does not exist. I'll briefly go through 14, but we do not do 14. We'll do 15 and 16 instead. Right. 14. So find critical numbers. Critical numbers are required to have two things. First, derivative equal to 0 or derivative does not exist. And whatever we have, the critical point must be in the domain. So we need to check with the original function. Because what the reason we check is because critical point or critical number are in the domain. So it is in the domain of the problem. So first, of course, we check derivative, so we can do the first part. 6x squared plus 6x minus 36, and then we just let it equal to 0. Does not exist. Equal to 0 is this, and you just do whatever we do for the quadratic equation. And this does not exist. This is continuous everywhere. For polynomial, we do not have anything on this side, so it's none. So whatever x we have here, we should check with the original function. Make sure the function are defined at those points. Right, so like that. I'm not going to do that because potentially that will show up on different problems. Okay. Do 15, and definitely we need to have 16. Something like 16 might not be on the test because that's a bit complicated, but I'm not sure, maybe we did that in class already. It looks familiar. But anyway, 15. So we take derivative, so we decompose. So it's 1/5 u to the negative 4/5. Derivative of this, it's just 1. Right. So we can rewrite as 1/5 u to the 4/5 at the bottom. Right. And u is x plus 2. And we do two things. derivative equal to 0, derivative does not exist. Here what we have is a fraction, and we always try to get to a fraction like that. So when a fraction equal to 0, that means the top is 0, and if we have a fraction equal to 0, the fraction does not exist, meaning the bottom is 0. So here we have 1 equal to 0. Of course that's not going to work, so we have nothing here. At the bottom, x plus 2 for fifth equal to 0. We can divide by 5 on both sides. And when a power term equal to 0, doesn't matter what the power is, the base must be 0. So we say x plus 2 is 0. So x equal to negative 2. Right. Almost there. We just need to check. So I put at x equal to negative 2, I put negative 2 back into the original function. It is original function. So we check that in the original function and it is defined. So yes, that is the critical number. Right, 16. I will rewrite square root of x as x to the 1/2. Also, problem may be a little bit long, so divide that in half. Right. So take derivative. This for 11, 26. Let me take a look real quick. I'll just have a question. Right. Yeah, we'll do that next. Right, derivative will be for x. This will be 64 times 1/2, and original power minus 1. That's the power rule. We have that, which we're going to turn this into a fraction. Right. The reason we need to turn it into a fraction because we're going to solve for this equal to 0 does not exist. The top 0, bottom 0. So we need to have one big fraction. So to do that, I multiply the denominator. So right, so that gives us x times x to 1/2 will be x to the 3/2. Right, so we have that. And then next two things. Derivative equal to 0, meaning the top is 0, and derivative does not exist. The bottom is 0. Actually, this one doesn't take a lot of space. We might as well finish on here. Anyway, so anything raised to a power equal to 0, meaning the base must be 0. The power doesn't matter. Of course, we're going to check this later, but just put that in the box for now. For this, I'll add the 32. And divide by 4. So we have that. Right, we'll continue over here. So x to the 3/2 power, we write that as power of 3 and root of 2. So the formula I use in this case, the power on top, root at the bottom. So square both sides. And then to get back to the cube or the x, I'll take the cube root on both sides. Under the square root we have plus or minus. The cube root, no plus or minus. So that's why we have x equal to cube root of 64 is 4. By the way, on your calculator, the cube root is under math, option number 4. Sorry, 4. So we have that. Right. Of course, we still need to check. And that's 0, that's 0, so that's 0, so that's good. We don't really need to know what it is equal to, but it is defined because square 4 is 2, so that's one good. So both of them are critical points. Right. I have a question on the chat that is number 11, 26, and 27. Right, 11 is, by the way, so derivative, if we have to take derivative of x by itself, that is too easy, just x. So whatever we do with the derivative at the end, we're just going to add derivative of x to it. For this one, we need to use the chain rule. So e to the box, and the box is equal to 5x squared. Right, and so that would be just for this term, and at the end we still need to have plus 1, which is derivative of x. Right, so we have e to the u and 10x, and usually if we just have one term like this, I'm going to write 10x e to the u instead. So 10x e to the u plus 1. So that is 11. Right. Next we go to 26. By the way, the application problem on number 27, we will do that on test 3, but we'll do that anyway. So 25 and 26, second derivative test. So what second derivative test is about? We need to do 2 steps. The first step is we must check the derivative. If it is equal to 0, meaning that C is a critical number. If it is not equal to 0, we're done and we say not a critical number. And we are done. Right, now if it is equal to 0, then we go to the second case. If the second derivative greater than 0, meaning that we open up, meaning whatever that point is, it has to be a minimum. So it's positive, open up, and there's a minimum. If it is negative, it open down, and there will be a local max. And if it is equal to 0, it is inconclusive. Right, now we'll take a look at this one. Right, we'll go there next. Right, 26. First we will take derivative. Will be 4x cubed minus 12x squared minus 24x, and then we test at x equal to 0. All of them are 0, so we just have 0, which is good, meaning that this is a critical point, critical number, so that is not the answer. And then we'll take the second derivative, 12x squared minus 24x, and we evaluate x equal to 0. Of course, I forgot the 24 here. Derivative of that, 12x squared, 24x minus 24. Right, 12 squared minus 24 24. So that is negative 24 less than 0, which open down, and there will be a local max. So yeah, we don't really need to find a point. If we need to find a point, we're going to put 0 back in here, and that equal to 24, and y equal to 24. But on the second derivative test, all I want, sorry, when I look at the problem, I think I didn't see the 3 there. So it'll be 12x cubed and 36x squared. Good thing is x equal to 0, so the rest of the problem is still just fine. I must do that when I do the problem. Anyway, so nothing changes because x equal to 0. So I should take the derivative, and that will be 12x cubed negative 12x squared negative 24x, and then take the derivative again. So that's why we have the second derivative test, because we do have the second derivative. Alright. 27 kind of different things, but we'll go over that quickly. After this, we'll go back to the whatever left of the problem. Right. So maximize the profit. So we start with the profit. Is the revenue minus the cost. So the revenue, that right. So simplify this, rearrange them at the same time. 0.02x squared, where 40x, I mean 480x minus 200, so will be minus 280x, and minus 100,000. Right. So that is the profit. Next, we want to maximize it, meaning we're gonna do like, actually what, we haven't done any of that in this review. So we find the critical number equal to 0 does not exist. Of course, we need to take the derivative first, which will be negative 0.04x minus 280. I think should be plus 480. Sorry. So yeah, next equal to 0. So negative 0.04x plus 280 equal to 0. So x equal to 280 divided by 0.04. We have 7,000. Derivative is this So we have none, nothing here. Next, we found x equal to 7,000. We just need to know that if this is truly a max. So I will take the second derivative. Got that, which is open down, which guarantee to be a local max. And the problem did not ask us for the x values, they asked for the maximum profit. So we're going to put 7,000 into this formula. $7,000. So we have that. Right. Next on the chat I have 1, 17, and 18. I'll do one quickly. Right. So on 1, right. We have the question asks us to use marginal cost, meaning the derivative. Is 0, so it will be 5 minus 2x plus 21x squared. So notice that this one producing the 8. Remember, if we want just the 8 term, what we really estimate is going to be, sorry, not that. If we want the 8 term, we're just going to need 7 of them. So let me find all of those problems and we'll see the consistent with that. So if we want the 9th values, we're going to estimate the one derivative or always one less than it. So this is always one more than what values we put in the derivative. So meaning that we're going to put 7 in here. Right, if we use the calculator. 7 is x, and 5 minus 2x plus 21x squared. Right, 10, 20. So the marginal is again the derivative. If on the test you instead of asking you to find the derivative of some function, I might just ask you to find the marginal of something like 1 or 2. Marginal is derivative. Right. So remember, it's always one less. I will not ask you to particularly do that, but remember, if you want the 9th or just one unit, one particular unit, then we estimate the derivative of the number before that, one before that, just like this. Right. I go to 16, 17, and 18, but I saw the question 7 and 8 on the chat, so I just briefly go through it. So this is like when we decompose a function. So put this in the box. We have the box to the fourth power, and the box is negative 5x plus 18. So we can just write one function is negative 5x plus 18, and the function before that is something to the fourth power. So you can use u or x or v, whatever the variable is. But if we just want to use x also, then we have x to the fourth. So that's how we decompose it into two functions, like where we using the chain rule. Right. Same thing here. Put that in the box. So we have the second function is negative 7x squared plus 15. On this problem, we will not need to do derivative. We just need to decompose it. And that's just square root of x. So, because we just set it up the function, so that's why we do not put u, and we just put x in generic the function of x. So square root of x, f of x, function of g of x, so it will be just that. Right, so now we go to 17 and 18. Right. Decreasing or increasing, it doesn't matter. That is what we need to do with the derivative. So what we need to do is, first thing is like this: find critical numbers. Not really critical number, just partition number will do. Anyway, so first derivative. This problem usually long. So divide that in halves. Right, two columns. Right, first I'll check derivative. 3x squared minus 4. Right. The reason this is a bit more complicated than it should be because of the fraction. We will see. Right, next. Take derivative equal to 0. Derivative does not exist. So we have 3x squared minus 4 equal to 0. Right, by the way, we have nothing here, so because it is a polynomial and no denominator, so that's all we have. Right, go a little bit slower here. And then I solve for x squared. Now to get back to x by itself, we will take the square root with plus or minus. So you can write square root of the top, square root of the bottom. Right, so that. We should check with the original function, but we do not need to because that is a polynomial. It's defined everywhere. So we only need to do this. The next is we do the sign chart. Organize. Right. So I have x derivative is 3x squared minus 4. the 2 points we have is 2 and plus or minus 2 over square root of 3. Usually, if we want to find the maximum or the minimum, we should check to make sure that the points are defined. But this is just an interval, so we don't need to do that. So of course, we start with the negative and then the positive. Right. Test point. Right. We know for sure 0 is between here. 2 over square root of 3. What was that? So it's 1.5, some 1.15, so we're going to choose 2 and negative 2. Right. So, because this is on the video, so you can go back and forth, so I'm going to go very slow on this one, so we know how to use the calculator. Right, so we're going to test those points on the derivative. Right, so I'll go with the start key and error. There's nothing there. If there's something there and we want to clear it, we need to highlight it first. Highlight the list, clear, and then now it's clear. Right, 3x squared minus 4. Do that later. For now, the values negative 2. Notice the negative is here, not the subtract. Negative 2, 0, and 2. And now we're done with the first list. When we go to the second list, very important things here. We make sure that list 2 is highlighted. So with list 2 highlighted, we're going to enter 3x squared minus 4. But instead of x, we use the list 1 here, which means second 1 square minus 4. And we have 8, negative 4 and 8, positive, negative, and positive, increasing, decreasing, increasing again. So we'll write increasing, by the way, on the back of or the solution on the back, they might have different representation. Sorry, they may have different representation, but we should have the same thing, the same values, that is. And then just write a comma in between, and then decreasing, negative 2 squared 3 over 2 squared 3. By the way, the question only asks for decreasing, so that is what we have. Right. By the way, the reason that we do not need to check this point because the interval of increasing or decreasing is just those interval. That's not including the point, so we really don't need to check. Right, so pretty much that. Uh, 18. The concept of 18 is similar. Right, so right, but first we'll take derivative using the quotient rule. So we check derivative. U prime v minus u v prime over v square. Right, so simplify this. We have derivative equal to negative 2x x squared plus 1 square. So that is the derivative. Next, derivative equal to 0. The top is 0. Derivative does not exist. The bottom is 0. So negative 2x equal to 0. That obviously 0. This x squared plus 1 square equal to 0. Doesn't matter what the power is, the exponent is. The base must be 0 for it to be 0. So we have that. Minus 1 on both sides. And taking the square root. For the square root we have plus or minus. That's in comparison with the cube root we have earlier. No plus or minus. Remember, only the even root where we have the plus or minus. By the way, what we have here is a negative inside the square root, which is imaginary. So this value doesn't count. We only have 0. Those not good. Anyway, put in the sign chart. Right. Only this point works because imaginary, that's no good. Again, we do not need to make sure we do not need to check this because we only check for the interval and not the point. So I use negative 1 and 1. Let's do the same thing here. So negative 1 and 1. Right. So to clear this, have to highlight it, clear, and enter. Highlight the list, clear, and enter. Right. So we have negative 1 will be on list 1. So negative 1 and 1. Right. Now I've entered that. Right. So we're gonna have that for derivative. So with L2 highlighted, so highlight L2. We have negative. I put an extra parenthesis. Oh, sorry. An extra parenthesis for the top. and an extra pair of parentheses for the bottom. And we still have square anyway, so it is positive and negative. So increasing, decreasing. And this question only asks for decreasing. Sorry, the question asks for increasing. I should read it. Right. By the way, I did mention in class, usually this problem is a little bit long, so I either ask you for the critical numbers, I only ask you this part, or I'm going to give you the derivative along with the point, and ask you to construct the sign chart. So either we do the first step or the second step of the problem. We will not do one complete problem on a test. Right. So that's for increasing, decreasing, and of course we can check whatever that point is will be the max, and that will be the mean, because the way the function go, we have that. Right. By the way, next we go to either 23, 24, or 22 to 24. Unless you have any other question, those will be the last question we have. By the way, if we want the maximum or minimum, then we just have those points will be the maximum or the minimum. Right. We'll look at 22 and then 24 then. Which kind of similar with the sign chart and all. What happened? Right, we're good. Yeah, so we do 19 then. Right, kind of same idea. Also a little bit long, so we will this instead. Right. So we check derivative. 3x squared minus 6x. All right. Yeah, I haven't showed this, but at least I have to do this on one at a time. The calculator on the computer doesn't have this app. I have that on my calculator. Right. So I'm going to let that equal to 0. Not exist. So equal to, so go to apps. Right. Right. Go look for that app. Right. Polynomial root finder. Again. That app names polynomial and simultaneous equation. Start with a P, polynomial. Right. polynomial and simultaneous equation. The 2 is meaning this is the version 2, so I hit that, hit enter. The first one, polynomial root finder. Right. We have a square meaning order 2, and we just hit next. Don't need to change after that. The coefficient will be 3, -6, and 0. This one because we can do by hand with no problem, but just want to demonstrate how do we do that using this app. So that 0 and 2. Alright, so of course we're just going to do this by hand. So derivative equal to 0. Derivative does not exist if the bottom equal to 0. So the top equal to 0. We have nothing at the bottom. Right, so I just factor out 3x, x minus 2. So if x equal to 0 or x minus 2 equal to 0. So x equal to 2. Right, so x equal to 0 and x equal to 2. This one we want the maximum or minimum, so we do need to check it. So we check with original function. I put 0 in there. And then check with 2. Eight. That's 12, -4, so that's -3. Let me cheat and just look at the test. Right, that's good. And then the sign chart. Like I said, on the test I will not ask you to do a complete problem like this. You might say something like finding the critical point or critical numbers, which will be those two. Or I will, on the test, if you say something like this, you'll be given the function the derivative and then the critical number. Yeah. So on the test you will be given this information and asked to find the maximum or minimum. You will not have to find it. Or if you find it, then you don't have to do the sign chart. Right. So x first derivative 3x squared minus 6x. The point we have is 0 and 2. And those are the test points. Right. You can do the test point, but on this one I try something different. We have 0 and 2. Those are the critical number. And derivative is this function. Derivative is this. I should not say function. Derivative is this. Parabola quadratic second degree. So meaning that it is a parabola either open up or open down. Since this one is positive, it open up. And if we have to fit those 2 points and open up, it have to go like this. Meaning it's going to be plus, minus, and plus. If we're not sure about it, we can always put those points into this function, and we expect to have positive, negative, and positive, increasing, decreasing, and increasing. Meaning the max is here and the min is here. So we write local max equal to something where x equal to 0. We do know now when x equal to 0, it is equal to 1. And local mean will be at x equal to 2. And we know when x equal to 2, it is equal to -3. Yeah. So again, on the test, you might see just that information along with the instruction. The question along with this information. And you just need to construct the sign chart and do this. Same thing on number 24. You will be given the derivatives, all the points to test, put on the sign chart, and then pretty much just this part. Have to have the sign chart. Right. The last part will be 22 and 24. And after this, I think we pretty much cover pretty much all the topics that are on the test. Right, inflection point. So inflection point is where we have to do with the second derivative. So first derivative, by the way, a little long problem. Take derivative 6x squared minus 30x. And then second derivative 12x minus 30 fraction. Yeah. Right. And then we let equal to 0. And does not exist. We have no thing here because there's no denominator. Right, 12x minus 30 equal to 0. X equal to 30 divided by 12, which is 5/2. So add 30 and then divide by 12, we have 5/2. Right, now, then we go to the sign chart. Before we go to the sign chart, I just want to point out these things. So first, on the number 19, we're asking to find the points, and the points we need to check. Inflection points, we're going to need to check. On number 17 and 18, find the open intervals of the function and something. And intervals, we do not need to check the points. Same thing on number 24 and 23. If it asks for the intervals, do not need to check the point. This asks for the points, meaning we need to check with the original function. At x equal to 5/2. And then put 5/2 into the function. Right. I use the calculator for this one. Right, 5/2. Wait. 5 divided by 2, store into x. And then we have 2x cubed. Remember the point we check, but always with the original function. The point is on the graph of the function. Therefore, we have to use the original function. Right. Change to fraction. -5/2. Right. Inflection point. Inflection point is not just that. We need to confirm that we actually have change in concavity. So we have 5/2. Right, 5/2 is 2.5, so I would choose 0 and 3. Then put in this function. We did this a lot. If we put 0 in here, that is negative 30. Put 3 in here, that is positive 6. So negative concave down, positive concave up. Because that's the smiley face and the sad face. Right. Now, what we need to confirm here is the concavity changing from negative to positive. So one up, one down. Doesn't matter which one first. So we say inflection point. Remember, it is a point. So we need to have x values and y values. Right. Now we go to 24, and I think that will cover everything. So that will be the last question. Right. Now, this asking for the function where it is concave up, concavity, concave up or down. We'll do the second derivative. Also, as for the intervals, not the points, we do not need to check like this. Right. So I'll take the derivative. Before we do that, I will rewrite this as 6 x to the negative 1. Then we take the derivative. And derivative again. Just take the power down and original power minus 1. Right. And I'll put that as 12 over x cubed. So second derivative equal to 0. Second derivative does not exist, meaning the top is 0, bottom equal to 0. The top is 12, it's not going to be equal to 0. The bottom is x cubed equal to 0. Doesn't matter what the power is, the base must be 0. Right, so we have x equal to 0. The question asks for the interval, not the point. Don't need to check anything. X, the second derivative is 12 over x cubed, and we have just 0. Right. The test point would be easy here, negative 1 and 1. So put negative 1 in for x. For the last part I just put in the calculator. Right, so first go to list. This problem is simple, but I just want to demonstrate. Stat, and there's something there. Wait, there's negative 1 and 1 there already, so we don't need to change that. Just clear the second list though. Right, and then we have 12 over x cubed, but always have to highlight the L2 first before we enter the function. So I have 12 divided by, I would put a pair of parentheses for the bottom. So we just do that. Of course, we can do this by hand as well, but just want to demonstrate here. So negative concave down and positive is concave up. The question asks for concave up, so it will be from 0 to infinity. So pretty much just take a look at the list, and we did cover everything required, everything that is on that list, on the checklist. Once again, on the test, I will not ask a complete problem. I either ask you for the first part or the second part. For the first part, for the second part, you will be given the second derivative along with the poem. Kind of like that. Just everything ready to put on the sign chart. Right. Anyway, I think that covers everything that needed for the second test. So I'm going to stop the video here, and thanks everybody who here for the live stream, and thank you for watching.